Hey guys, today we're going to be learning about separation of variables, which is 6.3 in the calculus AP book. Alright, so, oh my gosh, okay. Now, first, we have to go over what separation of variables are. When you see a differential equation with the form m of x plus n of y dy over dx equals 0, that means you can separate the variables and actually find the general solution, or the general solution of this equation. All right. So let's go over some examples. Number 1, we have x squared plus 5y dy dx equals 0. So yeah, so this is in the form that we just saw. This is m of x, this is n of y, and this is dy over dx equals 0. So what we do is we get all the x variables to the right and all the y variables on the left, including dy and dx, or including dy, and then dx would be on the right. So it would be 5, okay, and get everything other than y, try to get it on the right side, so all the junk. So what you would have is negative x squared dx divided by 5, and then y dy. So now you take the integral, and so you have y squared over 2 equals negative 1/5. You can bring that out. And then x cubed over 3. Right? So y squared equals negative x cubed over 5. Alright, let's do the next time. Let's see. We have y natural log of x minus xy prime equals 0. So this may look different because there's no dy over dx, but y prime, as you know, is dy over dx. So all you have to do is get all the x terms on the right side, all the y terms on the left side. So what you have is natural log of x over x dx. Oops, I hope in the last round I might have forgotten writing dy dx. That's very bad, so don't do that. And this would be dy over y. So, yeah. Okay, so now we can integrate. And you have to do u sub on the right side. On the left side, you have natural log of y equals u equals natural log of x, and derivative of natural log of x would be 1 over x, so it would cancel out, so you get the integral of u, so u squared and over 2, where u equals natural log of x. So this will equal natural log of x squared over 2. And now, to get rid of this natural log, you have to set both sides equal, or actually make each side equal the exponent of e. Right, so that would become y equals plus c. Oh no, I forgot the plus c too in the first example. Oh man, the first example is going to... never mind. Okay, y equals e to the, or ce, because you can bring the c out, because this is basically e to that times e to the c, and that's also another constant. So c e to the natural log of x squared over 2. Alright, let's go to the next example. Alright, last example, we have y prime equals 2e to the x. Oh, sorry, this is a minus, and that equals 0. Now, we have to separate, and so this will equal 2e to the x dx y dy. So y squared over 2 equals, this is after manipulate, y squared over 2 equals 2e to the x plus c. And now we're finding the particular solution when y of 0 equals 3. So this is the general solution. Now the particular solution, we have to plug in 0 for x. So y squared over 2 equals 2, and then e to the x, or e to the 0 is 1, so 2 plus c. And y is 3, so oops, 3 squared. So 9 squared over 2 equals 2 plus c. So we know that 9 squared over 2, or 3 squared over 2 equals 9 over 2, which equals 4.5, minus 2, so 2.5 equals c. And so the specific solution for this case, or the particular solution, I should say, is y squared equals 4 e to the x plus 5, because we're multiplying both sides by 2. And there's your solution.